Welcome to Stars Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Hi, and welcome to Stars Launch Pod, Space, Technology, and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise. Please welcome Thomas O'Sullivan, planetary scientist and computational chemist, working on the search for life beyond Earth and specializing in the icy moons of Jupiter and Saturn. This sounds really exciting. Thomas, welcome to our podcast.
Oh, thank you for having me. Great to be here.
Yes, I want to know more about you and what you're doing to help further the space industry. And this just sounds like a true passion for you.
Totally, yeah. So I'm a scientist here in Berlin at the Free University, and we're all about searching for life in the solar system, extraterrestrial life. And we specialize, as you say, in the moons of Jupiter and Saturn. What you'd expect to be quite cold places actually are able to host subsurface oceans of liquid water. They're sustained by the heat from the gravitational pull of Jupiter and Saturn and some of the other moons as well. And this all creates a warm, potentially habitable environment beneath an icy crust. So the moons in particular that we look at, one is called Europa at Jupiter. And we've got 2 missions on the way there at the moment, one from NASA, one from the European Space Agency. And the other moon that we're really interested in is Enceladus at Saturn. It's a really small moon, about the size of the UK or Arizona. And what's fascinating about Enceladus is that it's got this plume at the South Pole. And this plume is like a cold volcano. And it's ejecting material from the subsurface ocean. And it gives us 3 samples. So we had a mission there about 20 years ago called Cassini, finished about 10 years ago. And Cassini flew through this plume and sampled ice grains and gas containing dissolved ocean material, quite a complex chemistry. So really these are fascinating environments.
So when you're searching for life, are you thinking like on the microscopic level or something bigger?
Generally the microscopic level here. If you find something bigger, it's a nice surprise. But the sort of the basic assumption is that, yeah, we're looking for simple life.
So you've already gotten information back from the first moon you were talking about, right?
Yes, yeah. So we've had missions at both before. But because Enceladus has this plume, you're able to sort of get these free samples of the ocean without having to drill through 20, 30, 40 kilometers of ice that would block you from the ocean otherwise. And when we flew through this plume, bearing in mind that the spacecraft wasn't really designed to do this, this was a surprise discovery when Cassini arrived at Saturn. It had these instruments called a mass spectrometer. These give you information about the chemistry of a particle or of a gas that you sample. And when we flew through the plume and we turned on our mass spectrometers, we saw a range of organic and inorganic compounds, quite complex organic molecules, which may look sort of similar to what we expect to find on Earth. And so it's not enough to really understand if life is there, but it's certainly a good indication that maybe we're looking at habitable environments here.
That's part of all the excitement right now, because we went back to the moon, around the moon, and now eventually back, to the moon, I'm guessing, to get us ready to go further.
Yeah, absolutely. I mean, that's what the Artemis program is all about.
Yeah.
And, it's an exciting time, not just on the icy moons of Jupiter and Saturn, but Mars as well. The last sort of year or so has been really fascinating to see a few discoveries come from the rovers on Mars. Evidence of possible potential biosignatures contained in rocks, sort of long chain organic molecules, which look like they might be sort of derivatized from something related to biology, perhaps.
So is there going to be a way to get samples and bring them back so that you can actually get hands-on?
So from Mars, yes, that's always been the plan. Probably a little bit delayed now, but Mars sample return has been on the agenda for some years. From the moons of Jupiter and Saturn, it's a bit far at the moment for current technology. We're generally looking at one-way missions that will be able to do all of its science in situ. You may have orbiters, you may have a lander, which is the new plan from the European Space Agency, is to actually go and land on Enceladus, which will be the first landing on Enceladus, and search for life directly. If you have a lander, you can sort of carry more complex instruments. You can sort of be a bit picky about which samples you want to collect. with orbiters, you're sort of just flying through and taking whatever hits your spacecraft. But yeah,
It's
it's really
really,
exciting.
I was just going to say, this is really exciting. It's almost like a treasure hunt, and you just never know what you're going to find. How long have you been on this journey? How long have you been working in this area?
So I'm studying for my PhD at the moment.
Mhm.
I'm 2 out of 3 years in, but really now for the last 5 years or so, I've
Okay.
been fascinated by these moons.
Share with us maybe one of your aha moments during this time.
Sure, yeah. So we had a paper come out last year, which is my sort of first quite big paper as a co-author. And we discovered a range of new organic molecules in data from the Cassini mission in the plume of Enceladus. These molecules now sort of really start to build the jigsaw together of what
Mhm.
we've detected from Enceladus. And the stuff that we're seeing is the evidence that not only are our samples derived directly from the subsurface, we sampled them in this particular data set just minutes after they were ejected from Enceladus, and we found that actually the type of compounds that we're seeing and the distribution of compounds that we're seeing in this location is indicative of really a complex chemical network beneath the subsurface. And this hopefully will be the sort of starting point for a lot of different studies across the world. I hope people pick this up and
Yeah.
run simulations in the lab, run models on the computer, and really start to build up a good understanding of what's going on in a moon that is a couple of billion miles away. It's incredible to me that we're working on
Exciting.
this.
So, what's been one of your biggest challenges, and then how did you overcome it?
So in academia, the biggest challenge is always funding. It's
Yes.
always competition for grants, competition for scholarships, and this kind of thing.
Hmm.
So I've been working with this group in Berlin now for about 4 years, and I wasn't always doing my PhD, but that was kind of the end goal. I was fortunate enough that they were happy to have me and to stay on for a PhD, but there was no funding available from the university. So we went away, took about a year to write this research proposal. We brought in some collaborators from NASA, and we sort of put this piece together. And yeah, fortunately, it was accepted and approved, and I could start. But it was some money issues up in the air for a bit, but it all worked out in the end.
I know that as far as space missions and science and technology, a lot of it is the governments, but more and more is becoming commercialized.
Hmm.
Is that an area where you might be able to, get funding more in the commercial area?
Totally, it's as you say, it's an emerging area. We're seeing companies like Rocket Lab who are now looking at private missions to Venus, destinations where there's not so much of a commercial incentive to visit. And that, I think, is the challenge for us, is that, we're interested in purely the science, in the search for life. There's not necessarily a massive financial gain to be had from that. I think it's a massive societal benefit and
Right. Yeah, absolutely.
really, deep spin-off benefits. But from a purely monetary perspective, it's not always there. And so when you go and you compete in these open grant calls, you're up against commercial initiatives or
Hmm.
initiatives sort of helping human life on Earth. So it's a really competitive field, and that's always a challenge.
I want to ask you about when you're testing, when you're on on a moon or on one of these planets, is it done through AI? Is there someone manning the ship?
Mhm.
How do
No,
you do these experiments? I mean, how does that work?
yeah, it's a great question. So generally, at least for our research, there are kind of 3 different aspects to it. So the mission data, the mission is controlled by a space agency. Generally, universities will often build the instruments for that mission, and then there'll be a sort of, a science working group for each mission. I think now we'll start to see AI, the machine learning, sort of become involved. Actually, I think the Perseverance rover was recently controlled completely by AI for the first time in its sort of trajectory. But the data that we work with sort of before this AI bloom. So this was all, you would upload code manually, broadcast it to the spacecraft in situ at Jupiter and Saturn, and it would send back the data that it collects. So it has to be able to do all of this
Right.
half on its own, because there's a significant time delay to Saturn as well. And so, that's just, so you end up having the data sent back. Depending on the mission, depending on what's gone right and what's gone wrong, you may need to sort through that data on the spacecraft. You may have a limited bandwidth to send stuff back. So then you need
Right.
to have some sort of data processing capability on the spacecraft to handle the data and choose what is important to be sent back. That's not ideal. Ideally, you want it all sent back and for humans to be able to look through all the data themselves.
Right.
And now probably AI, machine learning techniques as well. But it's something that we can expect to see, I think.
Thomas, is this something that you've always wanted to do, or what happened 5 years ago?
Yeah, I mean, space was always my fascination. I'm pretty sure the first book I ever read was a space book from the BBC as a toddler. And all the way through school, always fascinated by it. I eventually went to do my bachelor's in astrophysics, and I kind of realized at this point, actually, this is something that I can do for my career. I can work in space, and I'm fortunate enough that I've got a topic that fascinates me. And at least up to this point, I've been able to pursue it. I went to France to do my master's at the International Space University, which was a really, really great experience. Very interdisciplinary. You get a lot of different expertise in many different areas, from space medicine to space law to architecture to astrophysics and planetary science as well.
How many people are on your team, and what kind of support do you have there?
Yeah, so we have a working group, at least in the Icy Moons group, of about 15, 20 people, all the way from bachelor's and master's students to senior professors. And we've got a really great team. We work with some fantastic people, many of which I'm lucky to call my friends. We have a really, really nice team. I think we do exciting stuff, so everyone's motivated. Everyone's looking out for each other. We're collaborating on papers and research and projects, working together in the lab, lending a hand to each other. So we've got a really brilliant team, an international team, people from all around the world. And I think it's really an enriching environment to be in.
It's good that you have that. I mean, you're a ways from home, so it's good that you have that support around you. Do you have any advice that you'd like to share with our listeners today?
I think something that I always like to push is that space is more than just technology. And yes, there's a huge drive toward commercialization, which is fantastic. But also it's still an active area of science. There is still so much we don't know. And the deep space missions, for me, are the ones that are most exciting, is that we're discovering.
And I feel like people are jumping and saying, oh, well, let's go here and build a habitat. Actually, you've got to crawl before you can walk. So you need to know the things that you guys are, researching.
Yeah, absolutely. And for me, it's one of the biggest questions that we can hope to answer. Is there life out there? And I think anything that I can do to help answer that question is good enough for me.
What is your opinion on that question?
There's no good answer. There's no diplomatic answer. I think there's life out there.
I hope so.
I really do as well. Of course, you have to come into it with the unbiased view. You have to sort of prove yourself wrong in your attitude. But I think it's why I do it fundamentally, is that I believe that we can find something.
It's a really exciting time, and I love what you guys are doing, and we will follow your journey and your path. Hopefully you'll have some big announcements, coming. Before we wrap up, do you have a passion project, either past or present, that you'd like to mention to our listeners?
Yeah, sure. So there's an organization that I work with called Europa. And Europa is, the name does what it says on the tin. It's a European planetary science non-profit international organization that brings together planetary scientists from across Europe. And we've got an early careers sort of committee group within that. I'm one of the co-chairs for that. And it's really, really fun to work with people from across, not just the continent, but the world, that come to Europe to do science. You do all these exciting activities, and you get to see what everyone's working on and the passion that people have for their projects. So that's something that's really close to my heart, is that we're building this community of people that are passionate about what we're doing.
I love that. That's kind of like what we do at LaunchPod, because we're a place where, somebody's watching our podcast today and you're talking about these things and they're like, ooh, I need to reach out to Thomas. I need to know how to get a hold of him. Well, we can connect you.
Totally.
We can do that. Yes. It's just another way to share all that knowledge. Thomas, thank you so much for coming on today. We appreciate it.
Oh, thank you for having me. It's been really nice. Really nice talking to you.
Thanks. All right. Make sure you join us where we connect, collaborate, and accelerate. If you enjoyed this episode, please leave us a review and subscribe. Until next time, keep looking up.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. Stars Launch Pod, propelling us forward, one launch at a time.